In this video clip, we develop an ARIMA model for time series data with both trend and seasonality. So firstly, we use time series plot to check for the pattern of data. Simple. Sales. Okay. Here we can observe an increasing trend together with seasonality with seasonal length of 12. So we have monthly data. Note that in this case, we use difference at a seasonal distance, that is with like 12, instead of regular difference with like 1. So we go back to the data and we go to state time series differences. We use sales. Here we can call DIF 12 at like 12. Here we are using the first order difference with like 12. Click OK. Then we check the pattern of column DIF 12. Okay. Now we see some fluctuations, but we don't observe an obvious trend. So we can examine ACF and PACF to determine possible models of ARIMA. Let me go back. Okay, here we go to state time series autocorrelation over DIF1. Be careful here, because of seasonality with seasonal length of 12, we want to see more lags regarding autocorrelation coefficient. We can use 60 here, given the size of data. Here we have ACF for DIF 12. Now we go back to the data and go with time series partial autocorrelation DIF 12. Again, let's use 60. By default, it will use 1/4 of the record. Here. Now we click OK. Okay, now we can view PACF together with ACF. Here we can see coefficient at like 1 is fairly small. However, the coefficient at like 12, seasonal lag, is very big in its absolute value. So we can examine coefficients at lags as multipliers of 12. We see lag of 12 here, and we see 24, 36, 48, and 60. Then we can see, on the other hand, PACF here. Be careful. Here the coefficient at lag 24 is also significantly non-zero. So here we can view the PACF as a pattern of die out for seasonal lags. But ACF, for seasonal lags coefficient, we can see the pattern is likely cut off. So here we can try MA1 model at the seasonal part. Okay, then we go back to the data, enlarge it, go to state time series ARIMA. The series is sales, feed seasonal model, period 12. we are using difference at seasonal lag and moving average for the seasonal part. So that's it. Then we click OK, or if we like, we can forecast for 1 year 12. We can store the results in a column if we like. For example, we can say C3 lower limit together with upper limits. We can use the column C4 and column C5. Okay, then we click OK here and OK here. Now we can see after altogether 13 iterations, the process stops, and we can find coefficient for SMA 12 with p-value tiny. The overall MS is 11,610 and 4. Regarding the residuals, the autocorrelations at lag 1 through 12 as a group has a p-value 0.25, which is acceptable. It's kind of big here. And here we can see the results of the forecasts. So this turns out an acceptable model for our problem. And if we go back to the data, because we selected storage, those forecasts, lower limits and upper limits are stored here, which we can use.